So our last presentation today is from Dana Vanderwall. So Dana, who I think most of you know, is the Senior Director at Digital Lab Consulting and previously Executive Director of Enterprise Informatics at Schrödinger, following 26 years in the pharmaceutical industry at Merck, GSK, BMS, Computational Chemistry, Cheminformatics, and R&D IT. His extracurriculars, when he has spare time, I guess, include contributor and leadership roles in the Allotrip Foundation, where he is a former chair, the Society for Lab Automation and Screening, Custodial Alliance, and INPAC. And so today, Dana's going to be talking to us about data strategy, right? If your strategy depends on data, you need a strategic roadmap to deliver data worthy of its aspirations. Go.
Thank you. It's good to be back. Yeah, so I'm going to speak to things at a little higher level. I'm not going to demonstrate the POC. We're not going to see any JSON. And the context of, what I want to talk about is that, as we all know, every R&D organization has some sort of aspirations around machine learning. It might be called data-driven decision-making. It might be called predict first. But it's there, and obviously, if they were only moderately engaged in that direction prior, the last 6 months has just exploded that. So there's leaders, there's experimenters, and then there's everybody else that's panicking for the fear of missing out, right? But it figures into all the corporate strategies at the most senior levels. What we also know is that the reality on the ground with the data is that most data pipelines, let's call it in general, the R&D pipeline, are not yet in a position to deliver to those aspirations. And without sufficient data, you're going nowhere with modeling. With poor quality data, or data that you're not sure is really comparable, you're just generating noise. Might be making worse decisions, right? That might be worse than no decision. So what I want to talk about is how do we close that gap as an organization? And so the points I'm going to talk through talks about a process to develop a strategy and a roadmap that you could look at across all of an R&D organization, that could be a department, or that could be just sort of one work stream. It scales actually really well, because it's really about connecting some of the lower level details with the big picture and continuously keeping both of those in focus and aligned. And essentially, that path to develop that strategy starts with an assessment, like where are you at now, and in particular, looking at that and creating a data-centric view. So we talk about data centricity, but I think far too often a lot of the people leading that are working in an application or a silo or maybe a department and have not yet transformed the enterprise to see things in a data-centric view. It's often pretty inside out from what's commonplace. Once you have that view, then you can start developing a blueprint for where you want to go. From that, of course, that includes data standardization as a key component of it, so I'm going to surface that, governing those standards once you develop them, and then a roadmap, a tangible, actionable roadmap to get there. And so, we're going to need glasses. Okay, so the assessment starts with talking to people in the lab, trying to get a job done and finding out what it is that they have to work with. To get a real picture of your current state, you have to understand the systems and equipment they're using, the processes, the expectations these people are needing to meet. But in particular, I want to focus again on what job are people trying to get done. And for people who are in product or anybody who's got interest in use cases, I'd recommend looking into the jobs to be done or jobs theory school of thought. It takes the idea of a use case and formally wraps around this notion, what are you actually trying to get done, as opposed to just being a contextual footnote. So this information gathering is targeted so that when you come out of this, you can do things like not just the key system requirements, that's pretty common stuff, but develop data-centric views of the entire business. How does data flow around the organization? And then also to support that, the flow specifically of data and materials throughout workflows in between departments. Part of this discovery phase goes to look to understand where are key data entities managed, where are they recorded. So at the end of the day, you might have a data package, and we've been talking about the context. There's all kinds of people upstream that ultimately have contributed something in an application or some note that they made to what make up that data package. What terminologies exist in the environment now? How are they being used? How are they defined in any naming conventions? And once you start to draw this big picture, you can start to say, okay, at a glance, what are our opportunities for more data integrity and closing these gaps in continuity? What are the technology and process gaps? So one of the first artifacts to come out of this that I think is useful is something like this data flow. So you can't read any of the boxes. That's intentional almost. But know that the sort of pink zone is research, the yellow zone is development, the green is CMC, and then you got the business unit. And each one of those squares is a piece of data or information that moves between these parts of the organization. The solid lines are things that are moving programmatically. The dashed lines are things that are moving manually in this particular case. So that's kind of painful. What's elucidating about this is very often an organization doesn't appreciate how much dependency they might have on people in other organizations upstream, or how many people downstream of them have a dependency on a piece of information or data that they're generating. The second is that deeper dive. So this is looking at a particular workflow. The notion of the samples is in the top lane. The second lane is kind of the high-level process steps. That middle lane is what's actually going on with data, instrument data, and in this case, files, and then finally you've got data storage at the bottom. So this doesn't look at all the human process steps. It's just focused on the data and the materials. What pops out of something like this is those little red boxes, or trapezoids. Each one of those is a manual step, and as you can see, each one involves a file, an Excel file, and maybe nominally structured data format. So developing views like this across these groups pops out immediately where some of your problem issues are, where investments are going to have the biggest impact. You can also figure out whether or not you're really running an optimal process, or maybe you're running a process that's actually defined by the tools that people have or don't have to work with. So with that kind of understanding of the environment, and of course, lots of details around requirements and lots of details around some of these other things, you can move to developing the future picture, the blueprint, if you will. And there's four main components to this. First is a very simple, high-level assessment of the digital maturity of the current state. Second is visualizing the systems, the equipment as a blueprint. Finding useful ways to summarize the findings and recommendations. A lot of times in some of these analysis projects, you extract out the requirements, maybe you draw a few of these pictures, but then there's a lot of detail kind of left behind on the floor. And when you get into execution mode, a lot of times you're kind of back there trying to look at some of the details. But there are some more useful ways to leverage that as you're trying to build roadmaps and the buy-in to move forward with them. And then finally, you need a roadmap, something executable. So this deceptively simple communication tool can be useful to sway people to understand what the current state is. And basically, you have a scale that goes from you're entirely paper-based to things through like, well, we're electronic and we're actually structured and kind of accessible, but the data's still kind of siloed and we can't really use it for prediction, all the way up to across the entire organization, you're able to use the latest technologies for analysis and insight. And you can do this at multiple levels of the organization. So it's useful to do it at the R&D level and then break it down to the department or workflow level, because people will be at different points. And why this is useful is you're doing some change management along the way as you start to read these things back out. And this is a useful way to keep more senior stakeholders that need the bottom line aligned with the folks on the ground. Because this is kind of saying, based on everything we heard on the ground, this is where the organization is. I don't know where you thought it was, but this is the reality. The blueprint itself is essentially a capability map. So if we start with the picture on the left, at the lowest level, we've got basic resource management, like compound management, reagent management. The next level up are things like the instrument and data capture levels. Above that, we've got the execution and the planning types of capabilities. And then above that, we've got things like the data centralization and integration type levels. And at the very top of the list are different ways in the yellow of actually leveraging the data and using it. Along the right-hand side are things like reference data management, semantic enrichment, user role management, project planning and tracking. And this picture is completely free of solutions. It's free of departments. It's really just the fundamental capabilities that are required to execute stuff that people are trying to do, that your organization is trying to do. And then what's useful is to map on top of that the current state. Right? This is the ideal picture on the left. And so you can do that both with dropping some icons and some color coding. So the sections on the right-hand side are, in this particular case, that are red. There's either no solution, or there's a solution that's really not meeting requirements at all. And so immediately, visibly, you get a pretty good sense of what the impact of any particular investment is on your overall model of capabilities here. Things that are in the orange boxes reflect there's something there, it's nominally functional, but it's really not meeting all of your requirements. It's not strategic, let's put it that way. And then the blue boxes are things where there's a solution there, it meets our requirements, it's playing into our future, it's fine. So again, that makes it really easy to spot your gaps and start to position your investments. And in my experience, once we get a good one of these capability maps, we reuse these things for years because it delivers a view of the organization, the needed pieces that really just doesn't come out of individual products or projects. And then, as I said, there are some creative ways to try to sum up some of the other things that you find in these interviews. Let's start at the bottom left. One is to take and look for themes in the types of pain points and gaps and things that people articulate and group them. So in this particular example, I've got some details. Data silos is something that came out of what people were saying that fundamentally reduced down to that. And then if you look at the table at the right, we've got things like problems with planning and forecasting, inventory management, no single source of truth, aggregating lab data, and so on and so forth. And there's maybe 15 or 20 of these things that you can come up with potentially, but we find that they vary depending on the organization, depending on where they're at in their journey. And associating these themes with these individual points becomes an important part of traceability down the road when we're trying to sell a roadmap and people want to know why we're investing in a particular scope of work. We can reconnect with these things and help people understand clearly which problems are being solved. And then the table up above that is kind of more mapping capabilities along the column headers versus particular solutions in the rows and just kind of giving a stoplight look as to what degree that particular solution provides those sorts of capabilities. And we pivot now and we think about how you build data standards into this blueprint going forward. I'm not, to this choir, I don't need to preach a whole lot about this other than to just bring it back again that, one of those important things is that normalized data and the value that brings to the organization that set its sights on some lofty machine learning aspirations. But the successful adoption of data standards and their governance really kind of rests on three key pillars. One is first defining the standards. The second is implementing governance. And the third is supporting that with the right kind of tool set. And so to define standards, you need to understand the scope of what you want to standardize, what's existing in the environment currently, what sorts of external ontologies and standards you can reuse, and then this is really simple, but sometimes it really underpins things that are very painfully tactical way. What are your rules for the identifiers? From the standpoint of governance, you got to put together the right team. So you need certain roles represented in the team. You need some structure, some process to that. people that are data stewards, and then ways to measure whether what you're doing is effective. And data governance is something that I think sometimes gets kind of a bad name because it's been approached at a very rigid and broad enterprise level, pushed from the top down. And there are actually approaches to building up really good data governance in a simple and pragmatic model. So I'd love to talk more about that later if somebody's interested, but it can be very effective and not painful whatsoever. And then from a tooling standpoint, you need a source of truth for your definitions, for your standards, some sort of catalog. You need an approach to align and integrate these things into the end user systems. That's one of the key points, right? So besides the data capture, and we touched on it a little bit about the details of how an experiment was done or why, you need to sort of start to push this stuff into the systems people are using to execute experiments. And then you need some kind of an ontology or RDM capability, management capability. So once you delve into this and start thinking about the scope of what you're going to standardize, as I said previously, you got to figure out where things are being created in the environment, what software applications, who or what is or should be the authoritative source, or is there a recognized authoritative source? So if different systems and people are defining what's a method and what's a protocol and what's a project in different ways, you're always going to have trouble aligning those things. And then really to get started, you need a base level conceptual data model. So sort of like the capability model, this is at a level of abstraction that ignores instruments, ignores departments, and it's just the most fundamental entities in your environment. And this overly simple illustration just gets to the point of what level of concepts you need to define. And this is sometimes, I think, undervalued, and probably most people will look at this and say, oh, I could do that. And you could. Anybody could. Any two people do one of these, they'll be different. And that's the problem, is that until you make it explicit and it's implicit, and people are making decisions what to capture, what to type, you have a continuous flow of chaos in your data stream. So you need to ground things initially with getting everybody on the same page about how you define these things, and this becomes your foundation for building it out further. Now, deciding what to standardize, there's two ways to approach this, and both are important. First of all, you have to go back and look at those pain points and gaps and those dependencies and what people are trying to do. That'll help you understand what data needs to be standardized, where the disconnects are. And then the other is, again, that organizational strategy. What's the aspirations for that department, for R&D, for the organization, and what level of data and standardization do you need for that? And then as part of agreeing on what standards to use and how to move forward, we'll get to a second, that process of looking externally and mapping those standards. And there are some things that are company specific, that's for sure. They can still be modeled in the same way, that's important, so you can manage them collectively. And of course, external standards can be extended where necessary, right? So just because it's 70 or 80% of the terminology you need, you shouldn't walk away from it. I've seen that happen. Rather, think about extending it, and then, of course, leave it better than you found it, right? The reason those external resources exist is because people contribute back. So Allotrope is one of the best examples for that, for an existing ontology. And then you can take that further and develop a detailed data model, master entity model. So if you think about those pain points, you think about what you're trying to achieve, look across various workflows, look at all the entities created and defined, and then start to map those to the external standards. Once you've done that, then you can have this built into your future architecture. So terminology, make sure that that's managed via a reference data management capability that cuts across all your applications. And then the format and the models for capturing data is fundamentally part of how you implement that layer for data capture and instrument data management. This is just a snapshot of the very rich set of resources that exist in the public domain, of course, the allotrope ontology, but to complement that, depending on the level of chemistry or biology that the experiments you're dealing with, there's lots of other workable, usable ontologies, particularly things like the bioassay ontology and OBI. And then there's great references for describing more about the things you're testing, particularly those biologically derived materials. So if you're talking about, say, a drug target, what biological processes and molecular functions of this thing is involved in. And those kinds of interesting contextual data are useful downstream, particularly maybe for the data science group or the bioinformaticians. You won't need it for experiment capture, but what is important when you're creating the experiments in the first place, that things like the proteins, things like the nucleic acids, are associated with the public ID, because then later somebody can actually map them to these other interesting contextual ontologies. And all of these things are publicly available, one or another of these three sources, BioCollit, OLS, and YoYo Foundry. And of course, for data capture, right, ASM and ADF are the standard. I don't need to say much more about that, other than, again, in your strategy, bake in data capture and the fundamental capability model for your environment. I want to address a myth when it comes to developing vocabularies within the lab-used applications, and that's, we can't use semantics in our ELN. Well, that's actually kind of beside the point, because the right process can still draw from those external references and have you clean up your data value stream. So even if the application doesn't have an API that can call some kind of an ontology manager to get a list of terms, almost certainly underneath there's a database or an XML file or something for configurations or terminology that appears in the menu gets stored. Where does that come from? Well, hopefully at least from requirements. Somebody asked somebody who knows about the workflow what terms to point and put in the vocabulary. On the other hand, that could also come from authoritative reference. So it's manual, but you could go get your terms and definitions from an external ontology and bake them into these databases. You have to maintain it, but it's better than chaos. A few words about governance. There's at least maybe 3 key roles required. Maybe 3 people, it might be 2 people. You need subject matter experts who, when somebody asks for a new term, they can look at it and say, that's a synonym of one we have here, but there you go. Or they could say, yeah, that's useful. Can we define it a little bit more granularly? Or, these kinds of conversations. So they have to understand the science well enough. They also have to be willing to talk to somebody who's more technical about the information modeling. So if somebody says, actually, that's a thing, and you need a word for a process, we don't get confused about that. And then you need the pair of hands that can go enter that into the place where this stuff is centralized. So I've seen that work where there is a committee of SMEs with an information management person on it, and they all kind of get the request, but somebody's responsible for the request at a certain point. I've also seen it where they create little teams, kind of domain focused, to handle this. But ultimately, once they get started, it turns out to be, and you have the bulk of your terminology established. It's not an onslaught, a request, and it's easy to handle with a short SLA. And that's the other thing you have to do, is the change management for people that need new words because they're about to run a new experiment. And one of the change management bits is to remind them that they actually knew they were going to need that new technique long before they decided to run the experiment today, because they probably bought an instrument or did assay development. So you just got to get people to think about this stuff more up front. And then, as I said, there's some useful tools out to help manage those references, whether they're a list of words or whether they're a fully semantic version. So all the problems you've decided you want to solve once you've mapped out what your data flow should be and where the gaps are in your capability map is you need to break these down in tractable chunks. And you can either do it by department, you could do it by work streams. That kind of depends on who and how you're driving this program. But nonetheless, with each one of those sort of work packages that you break down, define for each one of those the problem statement, the benefits, the goals, and then some of the high-level investments. And this is where maintaining that connection with those themes and those actual tangible pain points is important, because you can connect that up and roll that up into, we call them project cards for each one of those work streams. And then figure out how to sequence it, do it based on departmental priorities, pain points. You can do it based on, you have to figure in some dependencies sometimes. Some things have to be done before others. And an interesting approach I learned my year and a half at Schrodinger was sometimes it's useful to do the most risky thing first. Solve a really hard problem. Convince yourself and everybody else that's tractable, and then everything else flows from that to the extent possible. And then with a roadmap, you can convey this any number of ways. In this simple illustration, this is actually looking at different work streams and what value that they're going to deliver to the organization over time. You can pivot that to by resource, by spend, but because you've captured that up front, it's easy to spin those views multiple different ways. So the bottom line, to move the needle on your digital maturity, you need to do this. You need to really fully assess the current state, develop a data-centric understanding of the organization, build a blueprint, develop the roadmap.